Hi there, everybody. This video is to help you through the table in the feldspar section of assignment 3. And what we're talking about here is determining whether two mineral phases will be in complete solid solution with one another. And this paragraph will sort of explain that, but what we're going to do is we're going to measure the radii of two different cations in two different mineral phases, and then calculate the percent difference between them using this formula, and determine whether or not they are, if the difference between them, the percent difference between them, is less than 15%. If it is less than 15%, then the two minerals can be in complete solid solution, and that's what we're looking at here. So let's have a look at this formula real fast. The percent difference is calculated by taking x2 minus x1 quantity divided by x1, all multiplied by 100, where x2 is the cation with the larger radius, and x1 is the cation with the smaller radius. So again, we're measuring two different cations. We're looking at the larger minus the smaller, divided by the smaller, and multiplying that whole quantity by 100. Okay? So let's just get into it. What I'll be doing is the potassium in microcline compared to the sodium in albite, and then determining the percent difference and whether or not they will be in complete solid solution with one another. Okay? So this requires me loading both files in CrystalMaker, which I've done. So we have microcline on the left, albite, and that's albite low on the right. Before I move on, I want to say that you want to download these files, or at least ensure that you have the correct ones by looking in this folder, clicking this hyperlink, because there are two different kinds of albite, and just there's a lot of different mineral structures here, so make sure you have the right ones by looking in here. You can download them, put them in a place on your computer where you know where they are. You can go into CrystalMaker then, say File, and then Open, and navigate to that spot where you save them and open them up. You make sure that you have the correct ones. Okay? All right, back to it. So what I'm doing, again, is the potassium in microcline versus the sodium in albite. So what I need to do is, if the inspector tab is not open for you, pop it open, and then go over to the atoms inspector. And again, I'm looking at the potassium in microcline on the left versus the sodium in albite on the right. So sodium is the yellow, potassium over here is the purple. Now CrystalMaker makes this super easy. Determining the radius, it's right there. Radius in angstroms listed in a column here. I can see the radius of potassium is 1.43. Perfect. So 1.43, simple as that. Same thing with the sodium. I can just look over here and I see it's 1.16. 1.16. Great. Easily done. So now we know the two radii. And what we now do is use the percent difference calculation, or formula. And so we have to determine which is the larger, which cation has the larger radius. That'll be x2. The one with the smaller radius will be x1. So 1.43 is larger than 1.16. So potassium is x2 in this case. So as in the last video, I like to use Excel just for easy calculations. I have a column for x2, x1, x1 minus x2 minus x1, and then another column for x2 minus x1, all divided by x1, and then a column where I'm going to calculate the percent difference. And that's just to make things easier, not having to use a bunch of parentheses in the tiny little Excel boxes. Okay? So I'm just going to readjust my windows here so that I can see everything. So x2, the larger radius, is 1.43. The smaller radius is 1.16. Okay? Now we're going to subtract those two values. So we type the equal sign, move over to the x2 cell, subtraction sign, x1, hit enter, and then we're going to take that quantity, so I just typed equal sign and I've moved over one, so it's that quantity divided by, just using the backslash, the forward slash, I always forget which it is, but the little slash next to shift, and then, so we're going to divide by x1. Okay, hit enter. Now all we need to do to calculate the percent difference, you see I've done this whole quantity, and now I just need to multiply it by 100. So equal sign, that value, multiplied by, using the asterisk, multiplied by 100. And there it is. The percent difference is 23.27. So I'm going to round up and say 23.3. So the percent difference is 23.3. And now we have to think, is 23.3 less than 15%? No, it is not. So these are not going to be in solid solution. Okay? So again, make sure you're using the right minerals. Look in this folder, download them. Make sure you open the right ones. Use the correct elements for each one in the various mineral structures. Do the percent difference calculations. The Excel stuff is not required. It's just easiest for me. You can use a calculator if you want to. Do whatever makes you happy. Do pencil and paper. Okay, awesome. I'll see you in the next one.